All right, so in addition to the electron configuration, the periodic table also tells us a bunch of other properties of our elements. And we're called these the periodic trends. We're just going to go over a couple of them, and we're not really going to go into the reasoning of why behind them. We'll get to that as you move on to Chem 101. So first periodic trends is going to be atomic size. And so this is the size of the atom by itself in its neutral state. And what happens here, as we go towards the bottom left, we get bigger. Right, so the atoms closer to the bottom left get bigger and bigger, right? So going down the rows gets bigger, and going towards the left across the rows gets bigger. So for example, nitrogen would be bigger than fluorine, and potassium would be bigger than lithium. Note that we're pretty much just talking about our main group elements, so we're not really including the transition metals. So here's just this kind of same picture as up here, just basically disincluding all of these transition metals, which again, they kind of do their own thing, right? And so what you can see as you go towards the bottom left, you get bigger and bigger and bigger. So oxygen versus fluorine. And then let's take a look at sodium versus potassium. So for oxygen and fluorine, oxygen is here, fluorine is here, oxygen is to the left, so it is bigger. Sodium versus potassium, sodium's right there, potassium is down there, so potassium is lower, so potassium is bigger. One more caveat about this is that going down a row, has a bigger effect than going across a row. Right, so moving up or down the periodic table has a bigger effect than moving from the left to the right. So let's take a look at phosphorus versus selenium. So find them on our periodic table. Phosphorus is right here, and then selenium is right there, right? So if you think about it, one of them is below sulfur, one is to the left of sulfur. They're both bigger than sulfur, and they're both one spot away. So which one is going to be bigger? And again, what we're going to say here is that going up or down has a bigger effect than going left to right. So in this case, going down is going to have a bigger effect than going to the left. So our selenium is going to be larger than our phosphorus. Copy this periodic table. So another trend that we can take a look at is ionization energy. And so our ionization energy is the energy required to remove an electron. And so if we think about what the trends are here, it's the exact same as the atomic size. When we go towards the bottom left, the ionization energy decreases, so it becomes easier to ionize. And if we think about it, this makes total sense. For example, lithium, it already wants to lose an electron. That way you can have a filled valence shell, while something like neon has a filled valence shell, so it really doesn't want to lose an electron. So for example, if I asked you easier to ionize, you want to just pick out which one's more towards the bottom left. So oxygen versus nitrogen. Oxygen is right there. Nitrogen is right there. Nitrogen is closer to the bottom left, so nitrogen would be easier to ionize. If we think about sodium versus potassium, sodium is right there. Potassium is right there. Potassium is closer to the bottom left, so it is easier to ionize. In terms of going left to right versus up or down, that's not as clear. The trends here are not as clear. So don't worry about that. I'm only going to ask you atoms that are relatively to the left or right of one another, or are, you know, up above or under another. I won't go diagonal. So let's just say across versus down row, not as clear. as size, right? So some of those trends don't follow along. And then finally, the last periodic trend that we're going to go over is metallic character. And again, it's the same thing. Things towards the bottom left are going to become, in this case, more metallic. And if you think about that, makes sense. Remember that metals basically freely allow their electrons to move. And all of these guys want to lose an electron anyway, so they're pretty okay with giving up their electron to conduct electricity. So there are your kind of three periodic trends that you want to understand pretty well. When you go to Chem 101, you'll learn more about the why behind these trends.